In this video, I'll go over asymmetric cryptography. Asymmetric crypto uses two mathematically related keys, public key and the private key. The public key is used for encryption and the mathematically related private key decrypts. Asymmetric crypto also provides authentication, so we can be assured that a transmission or a message comes from who it says it came from. Data integrity is a part of asymmetric crypto also, so we can detect if changes have been made to data. However, it's generally considered slower than symmetric algorithms. With asymmetric crypto, the problem of distributing keys securely, even on a large scale, disappears, and that is a big problem with symmetric crypto, since the same key is used for everything. The public key can be shared with everyone. Private keys, however, not quite the same. They need to be kept secret to the owner. Keys can also be exported from a PKI or public key infrastructure certificate that's issued. Now, if we're going to export a private key, then it needs to be stored in a password-protected file. For instance, here in Internet Explorer, I'm going to open up my Tools menu, and I'm going to go all the way down to Internet Options at the bottom. Then I'll go to the Content tab where I can click the Certificates button. I'm going to go to the Personal tab here where I'm going to select a personal certificate that was issued to myself. Now, that could be issued by a certificate authority or a CA, or in some cases, such as with Windows, the first time you encrypt a file using Encrypting File System, EFS, you don't already have a user certificate, one will be created for you. However the certificate comes to be, when you select it here, you have the option of choosing Export down at the bottom. When you go through the wizard, you have the option of exporting the private key. Now, the public key is exported normally, and you might export the public key from your certificate to give to another user so that they can encrypt, for example, email messages that they send to you, because you will decrypt it with your private key. Let's dive into the email encryption example a bit further. Pictured here on the left, we have user Bob, and on the right, we have user Alice. In this example, Bob wants to send an encrypted email message to Alice. So what happens is that Bob encrypts the message to Alice with Alice's public key. So one way or another, Bob has to possess Alice's public key. Now, perhaps Alice exported it and provided it to Bob, or perhaps Bob was able to read that from a centralized address book. There are many ways to acquire public keys, and it's okay to share public keys with everybody. That's why they're called public. So again, Bob encrypts the message to Alice with her public key. Alice, on the other hand, will decrypt the message with her related private key, to which only she should have access. These keys are stored in a PKI or X509 certificate, and these certificates are issued by a certificate authority or CA. Now, the certificate authority could be within your company, or it might be a third party out on the internet. However, PKI certificates, and by extension their keys, eventually expire. Key pairs that are issued to users, or that could be issued to devices or applications, are unique. However, in some cases, they could be susceptible to a man-in-the-middle attack. Now, with a man-in-the-middle attack, we've got an impersonation of an entity that's already communicating with another party. So what could happen is that an impersonated public key could be provided to an unsuspecting sender. So a public key, of course, is used to send encrypted data, and we could be fooling someone, if we're the malicious user in this example, to send us sensitive information where the sender thinks it's going to someone else and it's encrypted, therefore protected. Examples of asymmetric crypto algorithms include RSA, Diffie-Hellman, and ECC.